All right. Good morning. This is Tim. Today is the 15th of September, 2025. Getting a later start today because I'm off this week and just decided to wait a little while to do this so I could have the National Hurricane Center latest update and talk about this system off the East Coast here. Uh, Interesting system here. Definitely have a low pressure off the coast. You can see it's quite asymmetric right now. Long-wave infrared showing a lot of convection on its western side. It's likely driven by this low-level flow enhanced and maybe some convergence um, or mid-level flow, excuse me. Likely this upper level feature is contributing to divergence here aloft, which is, we had the cyclogenesis off the coast and then this rotating through energy, increasing lift, and of course convection. So going back to infrared, you can see the low here pretty clearly. Lots of dry air on its eastern side. You go back to visible satellite. See this again. Lots of convection and shower and storms off the coast here. Look at the national radar. Take this off with the hazards. Shower and storms ongoing off the coast here this morning. So switching back to this, what are the chances of this becoming a tropical cyclone? I don't think, in the strictest sense of the word, it will, but this is a good way model guidance tries to classify it, right? And there's a phase space diagram with the ensembles, which is CMC, GFS, NavGem, and UKMET, 4 different models and their outputs. And it uses different parameters to determine whether it's symmetric, warm core, cold core. Cold core is a baroclinic, and warm core is barotropic, which means it's warm throughout and not frontal in nature, and the cold core is just the opposite. So the C is a current position, and we look at model consensus. Asymmetric warm core right now, forecast become symmetric warm core eventually, likely to remain shallow. So that's one of the reasons why I think that it will not be, it may become like a subtropical storm or a hybrid of some kind, and it may not, but it's really irrelevant at this point. The biggest threat, of course, is severe weather. And we'll look at that here. We have a marginal threat off the mid-Atlantic coast up into the northern tier on the Canadian border, the northern high plains, and then out to the west, with a 2% tornado risk off the coast here, and 5% wind damage threat here out in the western states, and a large hail, 5% risk up here and along the Canadian border. So for this discussion, I'm going to focus more on the threat on the southeast, on the mid-Atlantic coast, okay? And one of the things that's driving this is, okay, you have your 700 millibar flow, which is, between the 850 and 500 millibars and up in the atmosphere. You can see the enhanced speed, sorry, the enhanced speed and along the coast here, enhanced winds, right? With that moving through the flow and increasing as we move through time into tomorrow. And that's what's driving the severe threat part of it anyway. We go up to 850 millibars. You can see the lower better reflected near the surface here. And we have that enhanced flow. You see the greens and blues and up here as well. It's just some enhanced flow going on there, right? And so that is what's leading the SPC to have a marginal risk for tornadoes here. This is the surface reflection of this and the dew points and the winds, right? You see the surface low moving closer to the coast here, and you see the 70-degree dew points approaching the coastline, which when you have that much moisture with vorticity accompanying it and some instability, it remains to be seen what's going to happen here, but and up here you can see the same thing. You have the surface low moving off to the north, enhanced flow with it, right? So this is another way to look at this. You have CAPE, right, 1,000 joules per kilogram overlaid with the shear barbs and the contour. You see the shear right off the coast here, 40 knots or greater, and up in here in the northern high plains and the western states, right? Of course, the Cape up here in the along the Canadian border is greater today. Then you see that Cape moving on shore along the southeast coast in the morning tomorrow, and you see these dots, black dots, are the updraft Helicity swaths. So definitely have a chance of tornadoes, more likely overnight than anything. Just have to see how this plays out. If this plays out like it said, you could have quite a few, well, not supercells, but tornadic storms develop overnight. And one of the parameters we like to look at too with severe weather is 3 CAPE and vorticity. When they're overlaid on top of each other, you can see you have vorticity here in the blue and the 3 CAPE, which is the lowest level of the atmosphere at 3 CAPE. The more 3 CAPE, the better stretching capability of the low levels for tornadic storms to form. And if they're combined together in the same area, definitely have a chance for tornadoes. I won't be surprised you see tornadic storms up here. This is 6 hours out, so I don't have any way to go any further than this on this model. But anyway, you get the general idea. If this surface low out here gets a little further onshore, the vorticity associated with it gets further onshore, and the 3 CAPE does as well, you can definitely have some tornadic storms. And up there in up in the border of Canada, I wouldn't be surprised we have some too. So anyway, next I'm going to go over the rest of the tropics in the continental U.S. forecast. The tropical outlook here. As you can see on the screen here, 40% chance in the next 2 days, 80% chance of the disturbance developing in the next 7 days. Likely to move in a more favorable environment in the next couple days. And I agree with this assessment. East Pacific, we have Mario, which is like second life as a tropical storm here, and this other disturbance off the East Pacific coast of Mexico. And you notice from this advisory, they're still not hiding any areas off the mid-Atlantic coast, but I still say we should keep an eye on that. So, for the system out in the Atlantic, let's talk about this now. First of all, go out in the global satellite picture here. Quite a bit of convection associated with it. One could argue that we might be getting a low-level circulation developing here. We'll look at the visible from red here. Looks rather healthy. So, long wave infrared, a lot of convection ongoing here. And one of the things that's driving it, let's take a look at the mid-level water vapor here. Quite a bit of moisture at the mid-levels, lower levels. The upper level low to the north here. And there's some increased shear right to the north of the system, but likely contributing some divergence aloft with this. One of the things we can look at too here is the drier air around this system, and this is a good representation of it. Drier air, right, and dusty air is indicated by the deeper whites, and it's Saharan air layer, right, like right off the coast and up here, right, and the other yellow colors and reds are more indicative of just dry air aloft or mid levels, okay, and low to mid levels, excuse me. So, what does the Google DeepMind think of this, along with the European system? The European wants to make it a tropical depression, as do the rest of the models in the relatively short term, moving to the north of the Western Antilles, and maybe another depression developing out to the west, the east of it. European wants to make it a tropical storm as it moves to the south of Bermuda, become a hurricane, and then recurve out to sea. No other low pressures really in this model, okay? So let's see if I can get any more recent data here. Okay, so we have the European AIFS, Aurora, GraphCast, and Forecast IFS all have this system off the coastline here, the east coast of the mid-Atlantic here. And all these are temperature anomaly. These are MSLP normalized anomalies, which means the darker reds indicate higher than normal pressures, the blues lower than normal, okay? And so you see where the low pressure centers are. That one on the coastline gets absorbed into a larger trough. See the low pressure centers here as well. Although the Aurora doesn't really depict it that well. The Aurora kind of loses the system, the main system we're talking about here. But the European really wants to have like 3 distinct low pressure centers with all the systems really developing. I wish I could get this to behave for me. European off the coast here, a pretty deep tropical system here, as well as the GraphCast. Yikes. Just put this here. As well as the forecast and another maybe low here, but there's going to be some higher pressures building at the surface here in the longer term. So we'll just have to see what happens with that. Okay. But likely to become a hurricane when it moves out into the tropical North Atlantic. Okay. So there's some other models representation of the same thing. Going through time here. This is a 3-panel. The European global stops at 144 hours. There's still something to be said here for another system, maybe in the tropical Atlantic MDR developing, but we'll just have to see. And this is the ICON model, the UKMET, and the CMC showing low pressure centers, high pressure centers. You see the highs here, lows, different lows here, right? And through time, really the ICON only goes out 54 hours right now. And then the UKMET doesn't go much further out. The CMC wants to develop a low here, just like the other global models. So I really think there's a lot of support for this. This is the ensembles of the GFS and European. As we talked about before, the European has 51 members, the GFS has 31. And you see the area off the coast here. Not a lot of support on the GFS, but I think the GFS is out to lunch on this one. I think that the system's already there. So moving forward in time, that low off the coast gets absorbed. We have European GFS in quite good agreement in the shorter term. And then you can see quite a bit of spread. With some members that are weaker, maybe, I don't know, we'll just have to see. There's a lot of spread still in the guidance this far out, which isn't surprising. So we're talking up until 20 September, which is 5 days from now. And I think maybe the difference in the spread is due to the strength of the high pressure to the north here. Lower level, high pressure. GFS wants to keep the high pressure stronger up here to the north. So we'll just have to see how that plays out. This is an infrared satellite representation of the same thing, the European and GFS. This is what the model is trying to represent, the cyclone here. Over right there. See it? Okay. And then once it become a hurricane in the far north, in the mid, out in the middle, near Bermuda, and you get 240 hours out, the system in the middle Atlantic, not much happens with it. The GFS has been hinting at something in the Gulf of Mexico, but too much shear going on right there. Don't really see anything developing there. So this is the EPS potential development of cyclone, right? Tropical depression with 72 hours. Potential is really increasing here in the reds now, almost 100% chance of development of tropical depression in the next 72 hours. I think off the coast here of the mid-Atlantic, the system's already going to be gone by then. So there is a little support for depression off the Central American coast here. We'll just have to see. The other system down here, tropical depression, storm chances, even the hurricane chances here. 144 hours out. That's 21 September, which is 6 days from now. hurricane. Chances lower, but I think there's a good chance we could have a hurricane out here in the tropical Atlantic subtropics, by the 25th of September, which is 10 days from now, or 10 days from now, yeah. So that's all I got for the tropical Atlantic. And next, I'm going to talk about the Continental U.S. forecast. Here we go with the national radar. Again, we got the tropical chances out here in the Atlantic and the Pacific. Lots of storms ongoing right off the shore of the mid-Atlantic. Some storms ongoing. I'm going to overlay the current hazards as well. Into Mississippi was on the backside of low pressure here. And some convection going on the backside of a low, mid-level low moving to the north here. And some showers and storms in the northern high plains as well. You have a lot of air quality issues going on because of stagnant air here in the dense fog advisories, gale warnings right off the coast here, and some flooding threats as well. Right, and we actually have frost advisories in the out west here, so that's kind of interesting. And we have some dense fog advisories and beach hazards, dense fog as well. So overall, just on the coast here, we probably have a significant rip current risk and other things going on. So real quickly, we'll just switch to the satellite loop, visible satellite loop. You see a system off the coast here, strung out precip along this boundary here. And so that's that. Let's go to the outlooks. As part of this, let's see. Excessive rainfall outlook. Let's do that. Really, the only area we have here is right along the coast here, marginal risk. Nothing else highlighted today. Tomorrow, some of these areas, Nebraska, Mexico, Arizona, still along the Mid-Atlantic coast. Day 3, South Dakota, Nebraska, Iowa, centering in Colorado there. New Mexico, Texas, Oklahoma, Kansas. Moving day 4 and day 5, the threat along the Gulf Coast here. Of Florida, not the Gulf Coast, the eastern coast of Florida, South Florida, and a wide swath of marginal risk in the middle part of the country. Day 5, that area moves further to the east. Severe weather for today. Switching to categorical, we have marginal risk out here along the coast, Mid-Atlantic coast, up into the Canadian border, into the Intermountain West, Wyoming, high plains here. Driven by tornado risk right along the Mid-Atlantic coast. Wind taking a minute to load here again in Wyoming and the Canadian border. And hail risk up here along the Canadian border as well. For tomorrow, we got a 5% hail risk in the middle part of the country. Wind risk as well. Slow to load today. Tornado risk low tornado risk tomorrow. So categorical risk for day 3. Nothing on the board right now other than general thunderstorms. So let's see. Looking at the forecast temps, above and below normal. We show this every day, and total precip chances down here at the bottom right, and the geo potential height 500 millibars, which is a mid-level flow here in this pane. The temperature anomalies 850 millibars gives you a good indication where the warmest temperatures of the surface will be. So you get the hottest temps are up in Canada in the Midwest, really, in the short term, and that upper low, the mid-level low off the East Coast, and enhanced precip. You can see it here, and cooler temps, right in that area. Move through time here. High pressure builds. You have high pressure building in the middle part of the country. Looks like cooler temps. I mean, maybe a mid-level low, upper level low, cutoff low here in the middle part of the country. And the flow kind of flattens out, and you can see the warmer temps above normal for most of the country. Okay, but the southeast remains precip free till the end of the period, likely picking up some more precip. And this model wants to develop a pretty strong cutoff low moving through the flow here, which will likely lead to cooler temps, as you can see it here, reflected here and here. Dang it. That's what I don't like about these 4 panels. Anyway, you see the general trend. Midwest staying pretty warm for till the mid part of this, and staying quite warm above normal, but overall warmer temps for a lot of the nation. And then with a cutoff low being overhead, could potentially cool off some, but heat building back into the high plains and over the Rockies and into Texas, way above normal, at least if this model plays out. That's it for today, guys. Hope you'll have a great day, and stay safe out there.